All right, so welcome back. We are in our SI-SAS course, and we're now going into module number 3, which includes 3 separate lessons. We're going to talk about in this module certificate-based client authentication using EAP-TLS. We'll talk about authorization, how we can manage authorization within Cisco ISE, and then we'll wrap up with a lesson on Cisco Security Group Access as well as MACsec. All right, so the whole purpose of this module is to talk about a lot of the advanced access control functions that we see. For example, the Cisco Security Group Access solution, which uses device and user identity information that it gets during the authentication process to classify the packets as they enter the network. And then that packet classification gets maintained by applying something called an SGT, a security group tag, to those packets when they enter the SGA network, so that we can continue to identify and apply basic security policies and other policy criteria along the data path based on those markings. All right, sorry about that. So, we'll talk about SGTs. That'll be the last thing that we talk about in this section. We're going to take a look at MACsec, which is 802.1 AE. We'll talk about that standard and how we can handle encrypting packets between 2 MACsec capable devices and so on. So we'll get into a lot of detail on that particular lesson when we get into lesson number 3. But our first lesson is going to be a discussion about certificate-based user authentication. Primarily using something called EAP-TLS. EAP-TLS does have its advantages. It is an open standard. It's got lots of support, multiple vendor platform support, and so on. But there are some disadvantages as well, and we'll talk about that. So how do we use these certificates? We're going to describe the verification of client certificates themselves, describe the implementation procedures for certificate-based client authentication. We'll talk about how to identify the CA root certificate that's going to be used for verification of the EAP sessions. We'll take a look at how to deploy certificates on the clients themselves, how to configure 802.1x, specifically the 802.1x supplicant, so that it can use EAP-TLS, how to configure 802.1x supplicants to use the appropriate certificates, what do we do for certificate authentication, and then finally, we'll wrap up the lesson by talking about how to apply certificate authentication profiles to an identity source sequence and describe how to verify the EAP-TLS process. Okay. Now, as far as a protocol goes, EAP-TLS is again part of the extensible authentication protocol framework. In this case, it's EAP with transport layer security. Again, that was defined as part of the EAP standard in RFC 5216. It's an IETF open standard. It uses the transport layer security. It is actually considered to be one of the most secure EAP standards available because it does incorporate the use of these certificates in the process of communication. So we'll see, some description about how this process works on this particular slide, but we'll get into the concept of EAP-TLS as a protocol itself and how it can be used in Cisco ISE and how we can configure it in the ISE platform. To understand really in depth the concept of EAP-TLS, you do have to already have kind of a good understanding of how 802.1x works, and we've gone through that process. We also talked about how certificates work and the concepts of certificates as part of the process. So let's start by taking a look at the EAP-TLS flow and how bidirectional authentication works. EAP-TLS uses client-side certificates in addition to server-side certificates. Both the client and the servers have to enroll within the same public key infrastructure. Both the client and the server hold a copy of their own identity certificate and a copy of the CA's root certificate that we're going to use to verify the authenticity of the identity certificate that's being presented by the client or the server subsequently. When we set up the EAP-TLS process, both sides present their identity certificates to the other side, and then we're going to use that CA's public key to verify the digital signature on the identity certificate that was provided by the client side to the server or by the server side to the client. Because EAP-TLS does use bidirectional certificates, as I mentioned previously, it is considered to be one of the more secure options. We don't have to worry about passwords being captured or otherwise discovered because we simply don't use passwords in this particular case. EAP-TLS is an IETF standard, and just about every vendor out there does support EAP-TLS. It doesn't require Active Directory on the back end and so on. It is a very popular protocol when we're implementing BYOD in an enterprise, but there is a trade-off to having this additional security. It's the management overhead that's required to manage and provision the certificates in the environment. All right? So that's one thing that that kind of steers people away from this process is the need to control the provisioning and management of those certificates on the devices. But that can also inherently lend itself to a more secure environment. All right? There is a flow of operation that occurs when we connect, right? The wireless client or the wired client connects to the network access device, whether it's an access point or a switch. That network access device is not going to permit the client to communicate any data at this point. And then we're going to get an authentication request. The supplicant is going to respond with an EAP response identity, and then the network access device is going to communicate that user ID information over to the authentication server. The Radius component within ISE is going to respond back with the client to the client with an EAP-TLS start packet, and then at that point, the EAP-TLS conversation begins between the client and the server. All right. The peer sends its EAP response back to the authentication server, which contains a hello message, kind of a handshake, the cipher suite that's going to be used. In this case, the cipher suite is set to null until that gets negotiated. The authentication server is going to respond with an access challenge packet that's going to contain things like the certificate, the server key exchange information, certificate request, handshake messages, and so on. And then the client is going to respond with its own EAP response message, which contains the certificate, which the server can validate and verify that it's trusted, the client key exchange, the certificate verify piece where the client verifies the server is trusted, and a change in the cipher specifications or an accept of whatever cipher suite that we decided to use. Once the client has been authenticated successfully, the Radius server can respond with an access challenge, which contains the change cipher spec. And then once the client receives this, the client can then verify the hash in order to authenticate the Radius server and so on. We generate a new encryption key that's going to be dynamically derived from a master secret during that TLS handshake. And then finally, at this point, the EAP-TLS session gets established over the network, whatever process is involved, whether it's the client communicating over a wireless network or the client communicating over a wired network. We're going to find out in this section how we set this up in ISE, right? If we're integrating ISE with a wireless controller, or if we're integrating ISE with a network access device, there's a little bit of a different configuration scenario in each case. But in any event, that's the TLS process. So I've kind of discussed that a little bit. Let's take a look at some of the verification steps that takes place. On Cisco ISE, the PSN acts as our Radius server, as expected, that policy services node. And with EAP-TLS, the server uses the same process as the client does for verifying peer identity, right? I described that just a minute ago as I was kind of going through the steps of how TLS functions. both the client and the server are enrolled in the same public key infrastructure, so they both have their own identity certificate and the root certificate for the CA. There could be a chain of certificates leading to the root as well, but eventually we're going to be able to get to the point where we can actually verify and identify the authenticity of the certificate and verify the signature on the certificate that was presented either by the client or by the device. Hold on one sec. So the server uses the same process as the client. Like I said, these guys are going to be enrolled in the same public key infrastructure. The server uses the CA's public key, which is going to be obtained from the CA root certificate to verify the signature. And then obviously if that's valid, then the public key is installed in the client's certificate list, and then the client would be validated as well, and so we have that mutual authentication. The server challenges the client to provide that the client has a private key associated with the public key of the certificate, and then the client passes the challenge by doing various hashing and encryption and so on, and the client is then verified and identified in the same regard. That the server is identified to the client is identified to the server. All right. When we're going to install or implement EAP-TLS, there's a few steps that we have to go through. 6 steps specifically that we see listed here, and we'll see screenshots over the next few pages about how these steps look in the GUI when we're configuring this. But we're going to specify the identity CA root certificate for verification of the EAP sessions. We're going to deploy the certificates on the clients themselves, configure 802.1x supplicant to use EAP-TLS, configure 802.1x supplicant to use to use specific certificates, and then configure the certificate authentication profile, and then finally apply the certificate authentication profile to the identity source sequence. It's a pretty straightforward process. It's not overly complex, but it does require a few steps here. All right. So we're going to go to administration. We're going to go to system, certificates, and certificate store. And that's where we're going to be able to identify trust for client authentication or secure syslog services. We can check that box if we want to enable that for the root CA certificate for ISE to support EAP-TLS. When we're enrolling ISE into our public key infrastructure, one of the first steps is to process, one of the first steps in the process is to import the CA root certificates into the ISE certificate store. And then we do that again, like I said, under administration, system, certificate, certificate store. And we have to take that certificate file that we obtained either out of band or through some other method, HTTP or FTP or whatever method we used, we have to apply that certificate into our certificate store. Okay. And checking the box, trust for client authentication or secure syslog services. Even though we're probably not using this for syslog services, we definitely need to check that box for client authentication. Okay. That's the first step. The second step is to deploy the certificates on the clients themselves. Now, depending on the type of client that you have, will obviously change how you decide or how you actually deploy the certificates on the clients. The certificate deployment process for the clients will vary based on the supplicant type, based on the operating system. The Windows operating system has two different certificate stores, user and machine. The user certificate store is used when a user is logged in. If there are multiple user accounts on a single system, each user will have their own certificate store tied to that particular user. And we would see that in our Cert Manager application based on the current. This one is based on the current user, but we could see other users as well if we had other users defined on the system. The logged in user will be able to access their own certificate store, but they're not going to be able to access the certificate store of other users that might exist on that particular system. So the current user can use a certificate from their user store or from a smart card to authenticate to ISE. We see this a lot with like common access cards and so on, where I'm using a smart card to authenticate to an ISE platform. Then the user certificate store can be viewed, or managed using the Cert Manager MSC application or the MMC utility in Microsoft. The machine certificate store is always checked or consulted whenever EAP challenges exist or when there's no user logged in. It's used to authenticate the computer to the server, and the machine certificate store can be viewed and managed also with the same MMC program by those who have the right domain access or account privileges to access that certificate store. Again, the machine authentication would be either to authenticate the individual machine when a user is not logged in, or to maintain authentication of the machine once a user logs out after they had previously been logged in. Make sense? All right. Common 802.1x supplicants do not use EAP-TLS by default. The Network Access Manager for AnyConnect, for example, uses EAP-Fast by default. So we have to go in and set up NAM to use EAP-TLS. It has to be selected as the EAP method, and then the option to validate the server credentials also is selected in this case. And this is configured independently whether we're doing machine authentication or user authentication. In the Windows native supplicant, we need to also choose either smart card or certificate-based options. So we go under Networks, specify the EAP method, specify EAP-TLS, and then we can specify individual identities based on machine authentication and user authentication, and then specify that we want to validate this checkbox right here, validate the server certificates. So we specify EAP-TLS, we can configure the individual user or machine authentication properties. This is the native supplicant in Windows, enable 802.1x, and then we can specify here whether we're going to use protected EAP or smart card or other certificate. In this case, we would most likely select other certificate, and then we can check the settings button to go in and select the certificate options that we have there. All right. Next option, or the next step, would be to go ahead and configure supplicants to use certificates. And again, this is part of the credentials settings under networks. We go to prompt for credentials in the profile editor, or we can specify remember while the user is logged on. This will allow the users to log on with credentials, and then those authentication credentials will be passed to the server without having a prompt pop up on the screen so that the user has to re-enter their configuration parameters or their authentication credentials again prior to authenticating to the destination. All right. Typically, that's a setting that we're going to use. Prompt for credentials. We don't typically use remember forever, but only while the user is logged on. All right. If you select never remember, there's going to be a second authentication screen that's going to pop up, which is going to require the user to authenticate again, or instead of passing the Windows logon credentials over to ISE, we're going to have to re-authenticate and use those credentials and pass those over to ISE. All right. Certificate authentication profiles can be used in an authentication policy for certificate-based authentications. This allows us to verify the authenticity of the user. And there's a couple of different things we can do within the profile to create this behavior once we've authenticated with the certificate-based authentication. We can specify the certificate field that should be used as the principal username. Is it going to be a serial number? Is it going to be a common name, an alternative name, and so on? So we can identify the field that's going to be used as the principal username. And then we can specify, well, anything that's actually part of that X.509 certificate. Could be DNS, could be email, serial number, etc. We also specify whether or not the binary comparison of the certificate should be performed. All right. Now, what does that typically, when we're talking about binary comparison, we're basically trying to identify through a hashing process whether or not the certificate is valid or not, right? Cisco ISE basically gets the user certificate from the identity source, compares it based on each octet with the received client certificate, and there's we're going to obviously verify the digital signature of that certificate as well, but this allows us to identify the integrity of the certificate that's being presented by the client. Remember, client certificates don't have to be presented by the client themselves. They can actually be retrieved from, a client is always going to present a certificate in the authentication process. But in comparing that certificate with what we have in our data store, which could be Active Directory or LDAP or whatever, we're making sure that the certificate that's presented by the client matches the certificate that we're receiving in Active Directory or LDAP. All right, and that's what that little checkbox represents. Perform the binary right here, perform the binary certificate comparison with a certificate retrieved from LDAP or Active Directory. I don't know that adds really a whole lot of overhead. It could add another layer of authentication, or at least integrity checking, but doesn't really add a whole lot of overhead to the overall authentication process. Certificate-based authentication is an option that should be enabled in your identity source sequence if you're choosing to use EAP-TLS, of course. If you're not using EAP-TLS, you might be using another authentication method. Certificate-based authentication might not be required. All right, but we're talking specifically about EAP-TLS where mutual certificate authentication is required. When you do have this option enabled, you have to selectively choose previously defined certificate authentication profiles, like what we had just talked about on the previous slide. And then the job of the certificate authentication profile is to identify the fields that we're going to use to identify the client itself. Again, are we going to do a username or a machine name? Is binary comparison done? Is based on the copy of the certificate that we have stored in Active Directory or LDAP, and so on. Once this option is set in the identity source sequence, the identity source sequence is then in turn referenced by the authentication rule. We saw that in the previous lesson, the last lesson of module number 2. We talked about setting up authentication rules and identity source sequences and so on. All right, so AD_/internal was the identity source sequence that we had previously configured. And now we're identifying the certificate-based authentication piece that's tied to that identity source sequence. And then here is the list of identity sources that we're pulling information from. AD1 and then finally internal users. Does that make sense? Should make sense. It's pretty basic stuff. All right. How do we verify EAP-TLS operations? We go under Operations. So we click the Operations submenu, go into Authentication, and then we can see all of the live authentications. All right. In this particular case, we can see that at least 2 endpoints were authenticated using .1x, and over here on the right column, we can see the protocol that was chosen was EAP-TLS. All right. One was a user authentication and one was a machine authentication. How can you tell the difference? It's kind of self-explanatory, right? The bottom one is the user authentication. The top one is machine authentication, but both of them used EAP-TLS. This is very similar to what you might have to do on the lab on the test as well, where you have to identify how a device was authenticated to ISE. So remember, go under Operations, go under Authentications, and we're looking at real-time authentications in this particular case. Okay? You can refresh it. It refreshes every 1 minute by default, but you can change that refresh threshold if you want. All right? You can also click this little Details tab, and we noticed that in the Details tab, we were able to actually identify the identity source that was used to authenticate that individual user, whether it was AD1 or internal, whatever it might be. All right, so that includes the first lesson, and concludes the first lesson, excuse me. We talked about EAP-TLS and PEEP-TLS. Both sides verify each other using certificates. ISE has to have the appropriate CA root certificate installed to verify the clients, and conversely, the client would have to have the same root CA installed to verify the server as well. All right. In AnyConnect, we have a supplicant that we can choose EAP-TLS as the user and machine authentication option. We can use certificates and use certificate authentication profiles to specify the certificate field that should be used as the principal username. We saw that as one of the options that we could specify. And then finally, how do we take that certificate authentication profile and apply that to the identity source sequence? So that concludes that lesson. The next lesson that we're going to get into is the authorization lesson, lesson number 2, where we're basically going to talk about all of the different components of authorization that are applicable in ISE. Things like downloadable ACLs, authorization policies, rules and conditions that we can set up for authorization, and then configuring different authorization profiles and policy rules and so on. So we'll see you guys in the next lesson where we'll talk about, quite in depth actually, the authorization component of ISE and how we can incorporate authorization into our platform.